Hey guys, welcome back. Today we're going to go over one-step equations. Before we do that though, fact number 31 about me. I have this picture over here. It's a picture of a kid with braces, as you can see. A lot of you guys have braces. It's a pretty common thing for middle schoolers, for teenagers to get braces on. When I was a teenager, about 12 or 13, I also had braces. My parents were nice enough to give me some. I was honestly really happy about them because I wanted straight teeth, and I felt really lucky that they were able to afford it and do that for me because they cost a lot. If you don't know yet, braces are expensive. I had braces on for a couple of years. After that, they gave me a retainer. And the reason they give you a retainer is you put it in your mouth and it's going to keep your teeth straight and keep them exactly the way they were the day you got your braces off. That's the whole goal. They always said that if you didn't wear your retainer, your teeth were going to go back to where they were. After about, I don't know, 6 months of wearing my retainer pretty well, I kind of slowly stopped wearing it. There would be a day or two that would go by, I wouldn't wear it, my teeth were fine. There'd be a week or two that would go by, I wouldn't wear it, my teeth were fine. Then there was a month or two that would go by, my teeth were fine. And then the retainer would start getting really tight. And I was like, oh, maybe this is a problem. And then eventually, I just stopped wearing it at all because after a few months went by and not wearing it, it didn't fit anymore. So I stopped wearing my retainer. They moved a little bit at first, and then eventually they moved a lot. So much so that my teeth pretty much went back to right where they started from before I ever even had braces. The orthodontist is telling you the truth. Your teeth will go back to where they were if you don't wear your retainer. So when I was an adult, about 20, I actually got braces again. Braces as an adult, especially after you've already had them once as a teenager, is not fun. Mostly because my parents were not paying for them. I was paying for them this time. They were really expensive. They were about five or $6,000. I want to say they were about 5,500, right in the middle, about $5,500. And that was 10 years ago. I'm not sure how much they are now. I imagine they're probably around that price, maybe even a little more because everything goes up these days. Inflation is real. Prices increase as materials increase, right? It's just part of it. So, braces are expensive. Wear your retainer or you will not have straight teeth. Okay? Your retainer is important. It does make a difference. Okay? You do not want to pay for braces as an adult. You don't want to get them again. If you are lucky enough to get them as a teenager, wear them, treat them well, wear your retainer, and do what the orthodontist says. All right? So, anyway, let's get back to the math. We're talking about one step equations here. So, these are equations, and I know that because, oh, wait, let me get the pen going. There we go. Let me make it a little smaller. Too small. Let's see. Perfect. There we go. Let me move this down a little bit. All right, let's go through these. These are equations, and I know that because they have an equal sign. Expressions don't have this part. They don't have an equal sign or an answer. They would just have x plus 5. This, however, is an equation because it has an equal sign and an answer. So when I'm talking about one-step equations, I'm going to solve these. Expressions we simplify, equations we solve. By solving, that means I'm eventually going to figure out what x is. I want x equal to something, or I want whatever variable I'm dealing with to be equal to something. I want to find out what it is. The way we do that sometimes is probably just in our head. X plus 5 equals 12. If I think about it, I can probably think, what plus 5 equals 12? Let's see. 7 plus 5 equals 12. Easy, I know that. However, sometimes the numbers, especially now that we have negatives involved, they won't always be that easy. So we're going to show you how to do this if you can't just do it in your head. Now, a lot of you guys are familiar with this line down the equal sign. I'm not always going to draw this, but I will to start out with because a lot of you guys are familiar. That line separates the equal sign. It separates the left side of the equal sign from the right side. All right? That reminds us that whatever happens on the left side has to happen on the right side. So I have x plus 5 equals 12. That's actually the mouse right there. It kind of looks like 121. It's not. This is just a 12. Ignore that line after the 2, okay? X plus 5 equals 12. I have to get rid of everything around the variable so that I can isolate the variable and get it by itself. Currently, there's a plus 5 around the variable. I want to get rid of that. The way we do that is by using this, the inverse operation. What that means is I'm going to use the opposite operation to get rid of that. So, for example, if I'm adding 5, if I want to get rid of that, I'm going to subtract 5. Plus 5 and, I'm sorry, 5 minus 5, that cancels out and leaves me with 0, which is exactly what I want. And now this line reminds us that whatever I do on the left side, I have to do on the right side. So now I have 12 minus 5, which gives me 7. And then you can always go back and check your work because you can plug in that x value. The original equation was x plus 5 equals 12. I can go plug 7 in every time I see an x. 7 plus 5. Does that equal 12? Yes, it does. So I know I did that correctly because 7 plus 5 is 12. I want both of these sides of the equal sign to be the same. Let's look at the next one. Y plus 9 equals negative 3. So eventually, I want to get down to y equals something. That's solving this. I'll draw the line down the equal sign so that I remember to treat the left side of it the exact same as the right side of it. So I'm trying to get y by itself. To do that, I have to do the inverse operation. If I'm adding 9, I'm going to subtract 9. That's the inverse operation. And remember, this is subtracting 9, not just negative 9. It's subtracting 9. That cancels out, and I'm left with 0. I'll subtract 9 over here as well. So now I have y by itself, which is what I need. Negative 3 minus 9. Let's see, negative 3 minus 9. That's like plus a negative. That's negative 12. Perfect. Let's look at the next one. Again, I have a plus 7 equals negative 8. I want to get a all by itself to figure out what it is. So I'll draw the line down the equal sign. I have this a, I'm trying to get it isolated all by itself. I have to get rid of this plus 7. The way I do that is by using the inverse operation. So instead of adding 7, I'm going to subtract 7. That cancels out. I'm left with 0, which is exactly what I want. I'll subtract 7 over here as well. So now that's negative 8 minus 7. Let's see. That's like plus a negative 7. That's negative 13. Excellent. Let's look over here. I have x minus 6 equals negative 9. Again, the whole goal is to get x completely by itself to figure out what it is. I'll draw the line down the equal sign. Now I have x minus 6. I have to get rid of this minus 6. To get rid of minus 6, I'm going to add 6. I'm going to do the inverse operation. That cancels out. I'm left with 0 right there. I'll add 6 over here. So now x is equal to negative 9 plus 6. Well, that's just negative 3. Let's look down here. Y minus 8 equals 2. I'm trying to get y all by itself. Y is equal to something. I have to get rid of everything around y. Right now I have a minus 8. In order to get rid of minus 8, I'm going to add 8. I'll do the same thing over here on the other side. This cancels out to 0. So now I'm left with y equals 2 plus 8. That just gives me 10. Let's look at this one over here. X minus 5 equals negative 10. So I'm trying to get x by itself to figure out what it is. X minus 5 equals negative 10. Let's see. Right now the minus 5 is with the x. I'm going to get rid of it. The way I get rid of minus 5 is by adding 5. That cancels out to 0. Add 5 over here. So now this is negative 10 plus 5. Let's see, that gives me negative 5. And that is a negative 5. All right, let's scroll down. Let's see, there we go. Get back on the pen. Delete that. Let's move this out of the way. There we go. Let's look at number 7. Now this one is 3x is equal to 12. Let me rewrite it so we can see it real clear. Now there is no operation listed between the 3 and the x. There's no addition sign, there's no subtraction sign, multiplication sign, or division sign. Whenever we don't see an operation, we always know there's multiplication there, okay? We all know there's multiplication there. So in order to get rid of multiplication, I have to do the inverse operation. The inverse operation of multiplication is division. So in order to get x by itself, I have to get rid of that times 3. In order to get rid of times 3, I'm going to divide 3. I put this division sign right here. It kind of looks like a fraction now. This 3 divided by 3, that cancels out to just give me 1, which is exactly what I want. I don't want this to work out to be 0, because if it was 0, that would be 0 times x, which would just be 0. I wouldn't have an x anymore. We can't have that. We need the x there. So instead, I want it to be a 1 because 1 times x is x. Whatever I do over on that side, I'll do on this side. So now 12 divided by 3 just gives me 4. X is equal to 4. And then once again, you can always plug these back in. Every time I see an x, I'll put a 4. So 3 times 4, that equals 12. Oh, and it works. Yep, 3 and 4 is 12. And 12, I get the same thing on both sides of the equal sign. I know I did it correctly. Let's look at this one. 5y equals negative 25. So right now, this is 5 times y. In order to get rid of that multiplication of 5 there, I'm going to divide by 5. That cancels out to give me 1. I'll do the same thing over here. So y is completely by itself. It's isolated, which is what I need. Now I have negative 25 divided by 5. That just gives me negative 5. Look at this one down here. Negative 7x equals 21. Let me write this one over here to be really clear. Now I need to get the x by itself once again. Notice how that's the goal on every single problem, is to isolate the variable and figure out what it is. So x and negative 7. There's no operation in there, but I know it's multiplication. So right now, x is being multiplied by negative 7. In order to get rid of that multiply by negative 7, I'm going to divide by negative 7. I'm just going to do the opposite operation. But notice how the number doesn't change. Negative 7 up here, negative 7 down here. That's going to cancel out to give me 1, which is exactly what I need. Now x is by itself. I'll do the same thing over here. 21 divided by negative 7. That gives me negative 3. Perfect. And then if I went to plug it in, I would have negative 7 times negative 3, which gives me positive 21. I know I did it right. Let's look at this one. I'm going to write it over here just to have a little more room. All right. Now, this always looks really intimidating and confusing because it's a fraction, and that's always a little scary to see. All right. This is y divided by 7. That's what that fraction bar tells us. Just like the other problems, I'm going to do the inverse operation, the opposite operation. So if I'm dividing by 7, I'm going to do the opposite and multiply by 7. I always put parentheses around here to remind me to multiply. And now this is 7 times y over this 7. Remember when we multiplied fractions? It would be multiply the top together, 7y. There is a 1 under here even though we don't write it. 7y over 7 is what we get if we actually multiplied this out. And just like these problems over here, this 7 and this 7, they divide out to give me just a 1. So that cancels out. I'm left with y by itself. And then if I did it over on that side of the equation, I have to do it on this side. So now 4 times 7 gives me 28. I'm left with y is equal to 28. And if I plug that back in up here, I would get y over 7, which would be 28 over 7. Does that give me 4? Yeah, it does. So I know I did it right. Let's look at this one. Let me rewrite it. X over 4 equals negative 6. Right now, the variable, I'm dividing by 4. To get rid of it, I'm going to multiply by 4. I use the parentheses to remind me that it's multiplication. That cancels out and reduces down to 1, which is exactly what I want. I'm left with x equals 2. Whatever I multiplied on that side, I'll do the same thing over here. Negative 6 times 4, that's negative 24. Final answer. If I want to go and check, negative 24 divided by 4, that does give me negative 6. Perfect, I know I did it right. Let's look at this last one. A divided by negative 5 equals negative 3. So the variable right now, I'm dividing it by negative 5. To get rid of that, instead of dividing by negative 5, I'm going to multiply it by negative 5. Don't forget the negative. That cancels out. I'll divide by negative 5 on this side as well. So now I'm just left with A equals, let's see, negative 3 times negative 5. That gives me positive 15. If I went and checked my work, I would have 15 divided by negative 5. And that does give me negative 3. So I know I did it right. All right, you guys, thank you for sticking around for the whole video. And I will see you guys in class tomorrow.